All right, simplify the following expressions. Okay, go ahead. If you're like, okay, I'm going to see how I'm doing. I think I got this. Okay, go ahead and work ahead. Okay, and then just kind of come back when we get to it to check in to see how we're doing. Okay, so for example, same base, and we're multiplying, we get to add our exponents. Just one moment, please. Okay, so we have, okay, base of 8, and we're going to go 2 plus -7. Okay, guys, this is where your positive and negative integers also come into play for exponents. Okay, if your mental math skills, okay, could use a little bit of support, please pull your calculator to do these. Don't make like small little mistakes. Okay, so 2 minus 7, okay, gives us -5. Okay, we learned yesterday that our answer should always have a positive exponent. Okay, so if you ever have this, okay, you just want to change it so that it's a positive exponent. How do we change this to make it a positive exponent? Yeah, we're going to do the reciprocal. So a negative, okay, just means that we do the reciprocal of the base, okay, and then we do that. Okay, this, guys, I'm okay with either of these. They're exactly the same. Okay, so either put the 5 for the whole thing, or show that you understand that 1 to the power of 5 is just 1. And so when we simplified it, this technically is a little bit simpler than this. Okay, because we've just done the math on the 1. Okay, do I need to, like, this is a pretty big number. Okay. Hey, that one I'm going to keep that way. Hey, guys, what happens if my base is a decimal? Is that okay? Sure. Okay. If the base is a decimal, then the base is a decimal. You can just treat it like a regular number or even treat it like an x, okay? As long as you have the same base, you can still do your exponent laws. So that's one of the ways that they can kind of just spice this up a little bit. They'll just change the base and make it look like either a fraction or a decimal, okay? So what we're going to do here is we still have power of a power. So we're going to do 2.5. We're going to multiply -3 times -5. That gives us positive 15. Okay, so that's the first step, is we did power of power on the top. And now we are dividing the same bases. So when we divide the same bases, we can subtract the exponents. So we're going to go 15 subtract 5. So we have 2.5 to the power of 10. Okay, and because these are such big numbers, I'm okay with leaving it in simplified form. Okay, because this 8 to the power of 5 would give me like 32,768. Okay, let's just keep it 8 to the power of 5 for now. All right, this guy. Ooh, okay, we've got a lot of stuff happening in the brackets, but look at the beautiful gift that has been given to us. Okay, we have a to the power of 0. What is anything to the power of 0? Yeah, 1. Okay, so we don't have to do anything else inside of those brackets. Okay, we don't have to multiply the 3. We don't have to square the 7. Okay, our answer is simply going to be 1. Okay, but that 0 has to be like on the outside, and the whole bracket just becomes a 1. Okay, we just started on our notes. Okay. Okay, now we just like changed up the look of the brackets a little bit. Instead of rounded brackets, we've got some square brackets. Okay, don't let them worry you. We work from the outside in. Okay, so for example, the first thing that we're going to do is we're going to do this 2, and we're going to multiply it by the -4. Why would we multiply? Why wouldn't we add? Power of power. Okay, so when I'm doing these, I'm like kind of like repeating them. Power of power. That means multiply. Right, so I'm reminding myself of what I'm doing. So like we can write a few steps here. So here's our base. Okay, and I'm going to do power of power. So now I have -4 times 2 is -8. Okay, and I'm going to do the same thing for this guy. We've got power of a power happening here. Okay, so we're going to be multiplying, and we have -3 over 2. 2 times 3 is 6. Okay, so now I have same bases, and my bases are -3 over 2. But it's exactly the same as here, -3 over 2. Okay, so we can look at that and just say same bases, and I'm multiplying them. That's what the dot means, multiply. So now I just get to add my exponents. Okay, so we just write our base, add the exponents, And I end up with a -2. -8 plus 6 is -2. Okay? My final answer, though, can't have any negative signs in it, so I do have to keep going. I got to now deal with my negative sign. Okay? Negative exponents, easy. We just write the reciprocal. Okay? And that deals with the negative. So we write the reciprocal of the base. Hey, guys, there's a negative here, and there's a negative in my base. Do they have anything to do with each other? No. Okay? This negative, okay, just means we write the reciprocal of the base, whether the base is positive or the base is negative. Do not ever, okay, like change the sign of the base. Okay, the only thing we're doing is the reciprocal. So this is still negative. Now it's just 2/3. Okay, and my squared is still there. Okay, now for numbers like this, yes, I would like for you to actually give me the answer. Okay, so for this, I would expect 4/9. Okay, I took the 2, I squared it, like the -2, I squared it, and I took the 3 and I squared it, so that's where the 4 and the 9 come from. Okay. Now, sometimes we might, okay, have these like a long string of, okay, different variables with different exponents. Okay, all you have to do is kind of look at them in groups and then just do them in their groups. So my first group are my x's. Okay, same base, we're multiplying, right? You guys know that in between all these brackets, right, bracket times, you know, and bracket, but there's a understood multiplication sign there. Okay, so all of these terms here are actually all being multiplied together. X cubed times y squared times x squared times y to the -4. Okay, they're all being times. So with our x's, we can just add our exponents. So we have x to the power 5, and then our y's. Okay, same base. We can add our exponents. 2 plus -4 is -2. Okay, so do you see how our integer skills are now coming into play in our exponent unit? Okay, we're almost done, but not quite, because we do have a negative exponent. So that means that we just have to write the reciprocal of that. Okay, do we do anything? Do we change the x to the power 5? Okay, do we write the reciprocal of that? Because it's kind of like touching the y. Okay, no. Okay, this negative exponent is only attached to the y. It has nothing to do with the x. Okay, so this is what we talked about last time, where we said we can always write a bar underneath any of our groups. And when we have a negative exponent, that just means that this y is just going to drop below the bar. That's how we write the reciprocal of just the y and leave the x. So this becomes x to the power 5, and the y just drops below with a positive exponent. Okay? So if we have a positive exponent, or so if we have a negative exponent on the top, that variable just pops to the bottom. If we have a negative exponent on the bottom, the reciprocal of that would mean that that variable pops up to the top. Okay? This is, we've got that power of a product, which means that because everything's being multiplied in here, this squared, okay, goes to all three of them. So the 2 gets squared. Okay, guys, could we be okay and not write this? Could we just maybe do 2 squared in our head and write the 4? Okay, if you want to take the extra step to show 2 squared, I'm okay with that. But I prefer, like, let's just go to 4. Okay, actually do the squaring. Okay, we have m squared, and then we have power of a power. We're going to multiply those 2 exponents. 5 times 2, that gives us 10. All the way up. Okay. All right, so we saw some examples like this yesterday. Okay, and a really great strategy is just to kind of like group them a little bit so that you can see that numbers are with the numbers, the A's are with the A's, the B's are with the B's. Okay, so if you wanted to do that, okay, and just kind of like group, like make that a little bit more distinct, you can do that. Or if you're good with like leaving it where it is, you can kind of see it that way. But so this would be like 10, okay, And there's this like negative sign kind of there. So I'm just going to attach a 1 to the negative sign, okay, this negative sign here. And then I have an a to the power 5, and there's a squared on the bottom, okay? And then there's a b3 and a b to the negative 2. Okay, so I'm just like doing this, okay, and just kind of like splitting them up a little bit just so visually you can see that when we divide, we're just going to be subtracting those exponents. Okay, what is 10 divided by negative 1? Negative 10, yeah. Okay, so what happens is, guys, if we ever have a negative on the bottom, the negative just moves up to the top. Okay, when we write a fraction, we don't really write, I'll just write it here for a quick sec. We don't really see this very much, where the negative's on the bottom. Okay, the negative would float up to the top. We would see this, or sometimes we would see the negative right in the middle, but we never keep a negative on the bottom, just so you know. Okay, so if you have a negative, it's just going to actually come up to the top. Okay, so that was just a little, ooh, I did not like that. Erasing with a pen. Okay. So now we can do our a's. Okay, because we're dividing, we can subtract our exponents, a to the power of 3. Okay, maybe write this one down. Okay, because when we subtract negative exponents, don't forget we're going 3 subtract negative 2. Okay, remember what happens when we subtract a negative exponent? Okay, we're actually adding it. So guys, this becomes b to the power of 5. Okay, all of my exponents are now even, so, or even, positive. Okay, so I'm done with that one. Okay, this guy, I'm just gonna like rewrite it a little bit here. 8a3c to the 15 all over 4ac7. Okay, so you guys can kind of see that I've made these little groups just to be able to see what goes with what. Okay, do you have to do this grid? No, this is just me showing you visually. Okay, if you like it, go ahead. Okay, I'm just doing it just to kind of make the groups. 8 divided by 4 gives me 2. Okay, if you need a reminder, if there is no exponent, we can write the exponent 1. 3 subtract 1, okay, gives me 2. 15 subtract 7 gives me 8. All right. A couple more questions, and then we'll get you guys going up on the board to do some. Okay. So what, okay, now we're just like combining multiple things. So when you have options, don't forget, okay, before we start crossing things out, simplifying, okay, we want to make sure that BEDMAS says that we first look at our brackets. Can we simplify in our brackets? Okay, there's nothing more to simplify in the brackets. So then we move to the E in BEDMAS, which means exponents. That means this guy, okay? We're going to do this one first, okay? And then we're going to take a look at the rest of it. So let's write the top just as it is, y to the negative 3, okay? And then on the denominator, we're going to square the 3, which is 9. We're going to do power of a power, so 1 times 2 is 2. 3 times 2 is 6. Okay, now we're ready to simplify. Okay, so for some of you, you're going to take 15 divided by 9, and you're going to go to your calculator, and you're going to do your stacked fraction. I just did that wrong. Just a sec. Off of this. Okay, you're going to do your stacked fraction, and you're going to go 15, okay, over 9, okay, and that reduces to 5 over 3. Others of you, you're going to look at this, and you're just going to say, I'm going to be dividing both of these by 3, so I know that that is 5, okay, over 3. Okay, so it's either the mental math or you're using your calculator. Okay, then for exponents, we're subtracting because this is division. So 4 subtract 2 gives me x to the power of 2. Negative 3 subtract 6, okay, gives me y to the negative 9. Okay, which means that this whole thing is going to come down for my final answer. So my final answer is 5x squared all over 3y to the positive 9. Okay, this one, okay, I can simplify first and then I can deal with my exponent. So I can go negative 2a 3 b 4 a over 6 a 5 b 9. Okay, I'm just spacing it out a little bit more so that I can see, okay, I can divide. Okay, so what's negative 2 over 6? Okay, I can divide both by 2. Okay, we're going to simplify it like this, so it's going to become 1 over 3. We're going to subtract our exponents. So we have an a to the negative 2. 3 subtract 5 is negative 2. 4 subtract 9 gives me b to the negative 5. Okay, so now what I'm going to do is I'm going to take care of this negative. Okay, I'm going to write the reciprocal. So the reciprocal is now the 3 pops up, and I have technically I have a negative 1 on the bottom, an a to the negative 2, a b to the negative 5, and all of this is now squared. Okay, so all I did was write the reciprocal. I haven't like fixed anything. I haven't cleaned it up or anything. So now what I'm going to do is I'm going to square everything that's in my brackets. So the 3 gets squared. The negative 1 gets squared. Okay, power of a power. Okay, all of these things. So here's what it looks like. I end up with a 9 on top. This negative 1 becomes a positive 1. Okay, and then I have a to the negative 4, b to the negative 10. Okay, so my final thing here is, because of my negatives, that means that the a is going to pop up and the b is going to pop up. Okay, because we're writing the reciprocals. Right? Jot a couple examples down. Okay, so we end up with 9 a to the power of 4, b to the power of 10 in the positive. Whoops. That's my paper. Okay. You guys want to try some? I want to kind of see where we're at with this. So what I'm going to do today is your lucky day. I'm going to let you pick your own groups. Okay, so I want groups of 3, except there's going to be one group of 2. Okay, so head to the boards. Okay, and I'm going to put a couple questions up on the board for us to do. Okay, so we'll see how this goes. Okay. If you're not sure, just say hi, say your name, and say, can I join your group? Everybody's really friendly here. Yes, you are. You have early dismissal.